We're going to solve this example, which is to find Ix by superposition. So now when we look at the circuit, we can see that the Ix current is in the branch with the 50-volt source. Okay, so then when we use superposition, we make one source, one independent source active at a time and zero all the other sources. Then we find the response, which in this case will be for Ix, and then we repeat by making another source active and zeroing all the other ones until we've done all of the independent sources and we've computed a new Ix for each one, and then we add up all the Ix's. So in this case, we see that we have three independent sources, so we have three cases or three responses to calculate. So we have three independent sources. So we have three responses to calculate. Okay, so let's see what that looks like. So we'll do the first response, and we'll make only the 50-volt source active, and we'll zero the other sources. And then we'll compute I prime X. And that will be the first response. So we will label this I prime X. Okay, so now how do we zero the sources? Let's zero the 30-volt source. When we zero the 30-volt source, it becomes 0 volts, and a voltage source then becomes a short circuit. So let us redraw that branch with showing it as a short circuit. So let's just say that becomes a wire, and let's just denote in red that there was a source there, a voltage source, and it's been short-circuited. So now, what about the current source? Well, when we zero a current source, it becomes an open circuit. Okay, so then let's take that out of there, and let us just indicate by a dashed red line that we've taken that out, and that is an open circuit. Okay, so then now we can see a much simpler circuit than what we started with, and we see it's just a very simple circuit with a voltage source and some series parallel resistor. So all we have to do is calculate the current. So let's find the equivalent resistance. So the equivalent resistance is going to be like this. We see a 12 ohm resistor in series with an 8 ohm resistor, which is all in parallel with the 20 ohm resistor. Okay, so then this is 20 ohms, which is in parallel with the 20 ohms, and so our equivalent is equal to 10 ohms. So that was easy to calculate. Okay, so then what about I prime X? I prime X, and that's the first response, okay? V divided by R, and the voltage is 50 volts. The resistance is 10 ohms, and we have the correct direction. So then that works out to 5 amps. So that's the first response. Okay, let's calculate the next response. So in the next response, we're going to calculate when only the 20 amp source is active, and we're going to zero the remaining sources. They're both voltage sources, so they'll both become short circuits. So let us make them short circuits. So let's get rid of this guy, and let's get rid of that, and let's get rid of this guy. Okay, and so they're just going to be short circuits. Okay, and then let's just put in indication of where they were so that we know that we short-circuited them. So that's what happens to voltage sources when they get zeroed. Okay, so now we have to calculate Ix, and this is going to be the second response, so we are calling this Ix prime. Okay, that's the second response, so let's just label it properly. Okay, so now when we examine this circuit, we can actually see that there's going to be no current flowing through this 20 ohm resistor because it's shorted on both sides by the wire underneath. So we have no current flowing through the, I'm just going to do that in green. So no current flowing through the 20 ohm resistor. No current because the 20 ohm resistor is shorted on both ends. Okay, so this is very interesting. We just have a simple current divider in the remaining part of the circuit. We have the 12 ohm resistor and the 8 ohm resistor and the 20 amp source. And we want to, let's say we want to make it easy for us, let us calculate the current going this way, and let's call it I. And then, since it's in the opposite direction of I double prime x, let's just write down that relationship. So I double prime x is going to be equal to minus I. So then, let's use our current divider formula to calculate I. So then I is going to be equal to 8 ohms. Now remember, in the current divider we use the other resistor, or the resistor in the other branch, and then on the bottom it's going to be the resistors. So it's 12 ohms plus 8 ohms times the input current, which is 20 amps, and that works out to that works out to 8 amps, and then therefore I double prime x, which is equal to minus I, is equal to minus 8 amps. Okay, so that's the second response. Okay, and then for the third response, we are calculating for the 50 volt source only, or the 30 volt source only, and then we're going to zero the current source, and we're going to zero the 50 volt source. So let's zero the 50 volt source. So that's gone, and this becomes a short circuit. And let's put the indication that the voltage source was there, and that is a short circuit. And then when we zero the current source, we take it out because it is an open circuit. So let us indicate that by a dashed line. This is an open circuit. Okay, so that's the circuit as we see it. Okay, so then we have a similar situation, and we've already calculated the equivalent resistance up here. Okay, and this is the nice thing about superposition. It just simplifies the circuit. So this R equivalent, again, it was 12 ohms plus 8 ohms in parallel with the 20 ohms, and we know that that works out to 10 ohms. So then, and then of course we're calculating the third response, so it's I triple prime x for the third response. So let's just label it properly. Okay. And then so we can calculate I triple prime, and the current's flowing in the right direction, so that's perfect, so we don't have to compensate for it. So we have I triple prime x is equal to 30 volts divided by 10 ohms, which works out to 3 amps. Okay, so now when we calculate the total response, so that's going to be Ix, and that's going to be equal to I prime x plus I double prime x plus I triple prime x. So the total response is the sum of all of the responses. Okay, and so that works out to Ix being equal to 5 amps minus 8 amps plus 3 amps, and all of that equals 0 amps. So Ix is 0 amps. Now we would get the same answer if we were to apply nodal analysis or mesh currents to solve for Ix. We would get the same result as we did for superposition.